Hello students, welcome to this video on crystal field theory. I've made this video with the intention of reinforcing some concepts that was done in class. Have a look at this video and give me your feedback. Thank you. We have used this compound, potassium ferrocyanide, in the laboratory. It reacts with ferric ion to give us a beautiful Prussian blue coloration. This compound is essentially a coordination compound which comprises of a positive part of 4 potassium ions and a negative complex ion, that is FeCN6, having a charge of -4. Complex ion has a transition metal ion, ferrous ion, bonded to 4 cyano groups which are known as the ligands. Crystal field theory essentially tries to explain the nature of the bond between the transition metal ion and the ligand in a complex. Let's see what are the assumptions of the crystal field theory. The theory assumes the complex to be an ionic model. The transition metal forms a positive center. Ligands are considered to be point negative charges which produce a negatively charged field around the positive center. This is the picture of the metal ion at the center of a square plane. There are 4 ligands arranged at the corners of the square plane and 2 ligands occupy positions trans to each other. This is the diagram of an octahedral complex. As the theory says, the ligands approach the metal ion. Since they are considered to be point negative charges, they develop a negatively charged field around the metal. When we have negative ligands like fluoride, thiocyanate, cyano, or the chloroligand, it is very easy to imagine them generating a negative field around the metal. This is how, when the negative ligand approaches a metal, a negatively charged field is developed around the metal. It arises with neutral ligands like water, ammonia, carbonyl. How do these ligands generate a negative field? Ligands behave like point dipoles. Approach the metal, the negative end of the dipole points towards the positive center. We have a negative field being generated around the positive center in the complex. Two types of forces are developed in the complex. Obviously, because there is a positive center and a negative field, we have attractive forces developed between the positive center and the negative field of the ligands. And this attractive force binds the metal and the ligand in the complex. So essentially, the theory assumes ionic bonding in the complex. At the same time, we also have repulsive forces being generated between the electrons which are there in the n-1d orbitals and the negative field of the ligands. Due to these repulsive forces, there is a change in the energy level of the n-1d orbital. Crystal field theory is mainly concerned with the alteration or with a change in the energy level of the n-1d orbitals because of the negative field of the ligands. Hello students, once again. This was an introductory video which I have made on crystal field theory. As we move on with this theory in class, you will see it's a beautiful theory which tries to explain several complex concepts of coordination compounds in a very simple manner. Hope you all liked the video. I'll be back with a new video soon on a new topic. See you in class soon. Till then, bye-bye.